Welcome back. In this session, we'll explore NoSQL databases, reviewing what they are, why they exist, and then exploring the different types of NoSQL databases, including key value, wide column, graph, and document store. Finally, we'll build a NoSQL document store database in Azure so you can see it working and how to build it in a real environment. So let's jump straight to the blackboard and see what NoSQL is all about. So in order to understand what NoSQL is all about, we firstly need to start looking at SQL databases. And when we're talking about SQL databases, we're talking about relational databases. And with SQL databases, we need to understand what they're actually designed for. Now, if you think of a SQL database, the main aspects that they're designed for are around fixed columns, row-based data, and really adhering to a kind of fixed structure. And they're really good at delivering on those kind of promises, really, and functionalities. So it's very much around, you've got a particular structure for a database, you break it all up into different tables, you've got primary keys, references, all the rest of that. And it's really good at designing and being used to design for that kind of structure of data. Now, what they are not as good for is where we'll start seeing the kind of, not necessarily pitfalls, but the disadvantages sometimes of relational SQL databases. So when we start looking at things like distributed joins, and what I mean by distributed joins, when we have to perform sort of complex joins in SQL, SQL's incredibly efficient at doing that. So if we've got a customer and sales order data, joining that together, SQL eats that for breakfast. And it's incredibly efficient. However, it can become somewhat more complicated when we distribute data tables across different nodes. And this can actually become sort of more complex. So, and the reason this becomes an issue is when you start looking at things like scaling. So when you're scaling data, you've got two main kind of concepts. You've got vertical scaling. And this would be, in essence, employing a bigger server. So really what that means is more CPU and more RAM. And you can scale that. However, there's a limit to how big a server you can implement. And because of that, you then have horizontal scaling. And horizontal scaling is basically around more servers, if you think of it like that. So you can have smaller servers, but you'd have more of them. And then you can distribute the load across in order to do that. Now, vertical scaling, if you're going up to a certain limit, that's absolutely fine. Once you sort of start hitting a limit with regards to actual resources that you can gain in order to have sort of more CPU or more RAM, you then have to start looking at horizontal scaling. And then that creates more problems when we're talking about relational SQL databases, because what we then have to do is a concept called sharding. So sharding splits a database into smaller, more manageable pieces, but it also distributes the transactions over multiple nodes. So to maintain the integrity of those transactions, you need to basically synchronize the data between the kind of 1, 2, 3, however many nth number of sort of shards or nodes that you've got there. So in each shard has not only got to be accurate, but it also needs to keep in sync with the other shards as well. So because of that, when you start growing a SQL database horizontally, you've got a lot more overheads And that will bring forward some complexity and some potential issues when you start doing that on a large data set. So in summary, sort of relational databases are great, but it does have inefficiencies. And in particular, its shortcomings come into the data structure enforcement. So again, it's fixed data. So if we're inserting data into a table and it's got 100 columns and you only want to populate 2 or 3, it's going to take the space of 100 columns up because it needs to have that reserved should you be adding or editing, updating, etc. data there. So you've got to bear that in mind. And also with that, it's the enforcement that then can lead or has led to the development of NoSQL. So again, there's nothing wrong with SQL databases. They're very much used currently, and there is headways in the technology where actually some of these aren't really so much of an issue anymore. But it's worth bearing in mind that when you start looking at having different shards, that you then got to be aware of those particular overheads. If you are interested in learning more around SQL databases, I've got 2 videos, one which is an introduction to SQL, which I've linked above and in the description. I also have a second video that goes into detail around triggers, functions, and some of the more advanced pieces of SQL, which again, I've linked above and also in the description. So now we're sort of aware of SQL databases, the fact it's again adhering to fixed structure, and how when we get to scaling at much bigger sizes, that can actually start becoming a problem. What we can now look at is, well, okay, because of that, what does NoSQL offer, and how can that be used in situations where it can get around some of these issues? Because you can start storing data in a different way. So let's have a look at what is NoSQL. Well, let's firstly address the elephant in the room. NoSQL actually doesn't stand for NoSQL. It is short for Not Only SQL. And the reason for that is NoSQL actually allows for the SQL language in order to query. Not in all instances, but in most instances, it allows for that. So we were talking previously, or just a minute ago, around SQL relational databases. And although it's around the breakdown of data in particular tables, columns, and rows, what it also offers is the SQL language, which is a very powerful language in order to navigate the data. So even though we are talking about NoSQL or Not Only SQL, it's Not Only SQL because it also does allow, in a few instances, the use of SQL language in order to query the different data that we are going to be looking at shortly. So to understand what NoSQL databases offer, it's really good to have a look at what types of data are on offer. So let's look at those first. So when we're talking about the types of data, what we're talking about are the different ways that you can store that particular data. There are many different providers of NoSQL, Azure being one of them. Amazon also has its own offering there as well, and there's different providers and vendors. We're not talking about the vendors. We're talking about the sorts of data that you might want to store. So one of the first types is a document store. So with a document store, it does not require that all documents have the same schema. And typically, a document contains the data for an entire entity. So when we're talking about a document store, we're talking about no schema. We're talking about having a document of some sort. So I would call it more an entity. And really, it's great for developers because we are storing a a full entity within the document store, it means as a developer you can retrieve that back, and then you've now got an object that you can, in essence, instantiate from there, as opposed to query a database and then try and put it in such a way that you're then going to create an entity, maybe an order, maybe a customer from that. What you can actually do with a document store is you're storing, for instance, JSON. So as an example, you could have a JSON object stored within a document store, and that would then enable you to pull that back. So I'm just going to put on screen now an example document store so you can kind of visualize what this would look like. So here we've got our document store. So again, with a document store, we've got our key identifier, and that would then take us to our document. So in this case, we've got a customer order here with a SKU, price, ship to, and bill to address. And again, for another customer here, for Alice Brown. So again, because we're storing this as one entity, as we've stated here, we can retrieve that back and basically deal with that from a development perspective. It's all there. We haven't basically got to do a query to get all this information. So that's our document store. And when we're looking at document stores from an Azure perspective, they offer a document store as a Cosmos DB database. So again, Azure's offering, if you're looking to do a document store, you can use Azure Cosmos DB. Next, we're going to look at columnar data. So when we're looking at types of data, we're looking at 4 core types. And the first one we've just covered, which is our document store. The next one we're going to cover is columnar data. So type number 2, we're then looking at columnar data, or a columnar store. Now, one thing to note is that columnar store or columnar data is also known or commonly known as column family. And what this does is it organizes data into columns, but also rows. And this would be similar, although it's certainly not the same, as SQL, or regular SQL as we know about it, relational databases. But the real power of column family lies in the fact that it's actually denormalized data. So what I'm going to do is, again with the previous one, I'm just going to bring on screen a snippet of what columnar data could look like. So again, it is very much columns and rows. However, what's really key here is you've got a key that can then bring back different sort of groups of column data. So here we've got a column family around identity, where we've got a first name and last name for Dave Smith. But if we look further down, our record or customer ID 3 has a first name, last name, actually has a title where there's no title declared for the other 2. Again, it's allowing for denormalized data. What you then can do is within the same sort of row, you can then have secondary and subsequent column families where you've got groups of different data. So we've got customer ID here, and then we've got an employee number and title here, an employee number here, and then again an emergency contact here. So even though we've got different groups of data, different columns of data, it doesn't actually need to be organized and as strictly structured as our SQL relational data. So, and unlike document or key value data, which we'll cover shortly, most columnar data is actually stored in key order, which means that when you hit a particular record, you can very quickly and easily get the other related column data back. So it's a really nice way of having dynamic data grouped in such a way. And with this, again, if we look at Azure's offering, this is offered by Azure Cosmos DB for Apache Cassandra. So again, we've got that offering with Azure that covers us being able to implement this within the Azure ecosystem. So that's our second data type. Our third then we're going to look at is key value pair. So let's look at that now. So let's just grab this, bring this down here, and let's explore what a key value store actually looks like and what it offers. So when we're looking at a key value store, it is essentially a big hash table. So we are very much looking at having a key and then the subsequent value attached to it. So if I just pop this here, we can see we've got an example here where we've got a key which contains a person's name. And then we've got a value here, which in this case is a telephone contact number. And that's really what it's all about. It's about having a single key and a single value. So again, it's massively simplified compared to the likes of a document store and columnar data, but it's incredibly useful because the data is light and quickly accessible. So with this, you would link each data value with a unique key. So in this case, we've got this key Paul, Fred, and Marco here for the various values within this sort of snippet here. And what that does is it stores this as basically using a hashing function. So when we're creating these from our visual representation, these are like row 1, 2, and 3. If you think of it in that kind of way, although it's not really being stored necessarily like that. But it's actually being hashed, and hashing is selected in order to enable even distribution across your key storage. So again, it enables fast access, the best use of this data store that you're using in order to store that data so that can be brought back. So what we do have here is we've got a hashing function for even distribution. If I can spell, there we go, for even distribution across the data store itself. And then also we've got to bear in mind that most key value stores only support simple queries. So we're talking sort of simple sort of querying, simple inserts, and sort of your updates and deletes, etc. And what that means when we're talking about simple is they're normally built around, or they're not normally built around and designed for just the sort of where clause side of things. When we're talking about we're bringing back for a particular key, what we can't do is use where clause filtering for non-key columns. So it is just literally using it for the key. We can't then go, well, actually bring back all records that start with value 212, for instance. It's not around that. So it is literally where for key value only. And again, we're talking about the Azure offering for this, because I think, again, it's good for showing the specific implementations that are available for some of the ecosystems we're using. So we talk about Azure. Azure offers this, again, using Azure Cosmos. And again, this is Cosmos for table. And we've got the Azure table storage. So again, there may well be more implementations for this, but these are two that Azure offer for our key value store. So that's our third one. Our fourth one is then graph. So let's have a look at that now. So with graph, again, we're talking a graph store. Graph's quite an interesting one here, and I think descriptively we've got some very practical examples and usage of the graph type for NoSQL. So when we're talking about graph, it manages two types of information. The first are what we would call nodes, and the second are edges. So graph is all around nodal data. So what we're in essence doing is we're storing our data as nodes. So this would generally be like an entity, basically. So we would store entities in our nodes, and then edges, you can think of these as relationships. And it's relationships between the different nodes and entities. And a really easy example of this would be something like Facebook. So I think most people have heard of Facebook and have used Facebook. So Facebook, the idea is you create your own Facebook page and you're registered on there as a person. So there's, Luke, for instance, on Facebook. And then, for instance, I will have multiple relationships with other different people that are on Facebook as well. And they're then classed as my quote unquote friends. And what that's all around is having different entities being stored. And then you store the edges, the relationships between those. So again, it's very nodal. And if I bring on screen here, we've got this example here. So you would potentially have someone here that's created or has a entity within, for instance, Facebook. And then they would have different edges and relationships between different other people within Facebook as well. So by doing this, you then have a very nodal view of, or nodal model of how that data is then stored. And what's really good here is because it's built in this way, it's really good for storing large quantities of relationships and entities, and you can perform incredibly complex analysis quite quickly. So if we put on here, so we're talking sort of complex relationships and huge nodes, and from within that we can very easily query. We can easily build up different data sets based on that. So for large graphs with lots of entities and relationships, we can perform those complex analysis quickly, with many graph databases providing a query language that you can actually use to traverse the different networks and relationships. That's easy to query. And then there's generally sort of APIs offered for sort of querying that data. And from an Azure perspective, this is offered through Azure Cosmos DB, and then there's a graph API. So what we've done here is we've gone through NoSQL, and we've had a very high level overview of the different types of storage we've got on offer for NoSQL solutions. So we've got our document store, we've got columnar data, key value store here, and then we've got our graph store here, which again is around all of that nodal data. So now we've got a really good grasp of the different types of data. What we're going to be doing next is we're going to be exploring Azure, and we're going to create a document store where I can show you how that would look, how you would build it, and then you'd have the ability there to be able to use that document store within an application somewhere. So you can build something within Visual Studio that can connect to that database, update it, view it, etc. And then what you've got to think about from a document store perspective, which is really great, if you suddenly get back this document here, which is around a customer order, you can very easily use front end logic, code, etc. And it's really a front end piece in order to present this in a particular way. So it can make development really straightforward, because instead of being able to deal with the overheads of a database in order to collate that data and create your object, that object is already just being stored raw as what it is, and you can pull that back now and use your front end to display that data in a nice fashion. So let's jump in now to Azure and look at creating an Azure Cosmos database and create a data store. So we're now in Azure, and it's from here where we're going to create our Cosmos database. So firstly, it's good to create a resource group, which is just a way of grouping particular applications. I've created one here called Database Demo. And from within here, I'm then going to create a resource. And the resource we're looking to create here is a Cosmos database. And here we go. So we can just hit create. And here we're going to create an Azure Cosmos DB for NoSQL. So there is an option for creating one using Mongo, but we're going to use Cosmos here. So hit create. And then here we need to populate some information around the type of database and workload that we're going to be using. So here we're just going to create one for learning. Again, this is going to be sort of a throwaway instance of a database just in order to demonstrate a NoSQL database. So this is all set up for the resource group, as you go, that's fine there. Now we need to come up with an account name. So this account name is going to form part of the endpoint to connect to this database if you were going to use something like Visual Studio or some sort of development tool in order to kind of connect to that particular database. So we're just going to call this LS Demo Cosmos. Is that available? Perfect. I'm going to set the location, so West US, that's absolutely fine. For capacity mode here, we are purely going to leave this as provisioned throughput, so that's fine. I mean, we could choose serverless, but we'll go for provisioned throughput. And here we get the first 1000 RUs, and RUs are like resource units. So every time you do a query, and I'll cover this later, there is a kind of computal cost for that. So as part of this particular account, and most people have accounts that you set up here, you'll get a certain allowance for RUs and storage limits here. So we're going to apply this and allow that to be applicable for this account. And here we can simply select review and create. Again, we're not doing anything clever on setup on here. We can then hit create and then allow Azure to start creating and deploying this resource. Now, this can actually take a short period of time because Azure needs to spin this instance up and create it. So as soon as this is ready, we can then actually jump into this resource and start looking at how we create our tables, in essence, our document store within our Cosmos database. So it took a little while there, but we're now set up the resources there. So just click on resources. And then we get taken to our Azure Cosmos DB account. And it's here where we land on the quick startup, but I'm just going to jump to overview. And it's here where we can see things like the status. So it's online. We also can see the URI here for linking to the database if you're connecting to it externally, and also the details around where it's hosted, etc., total throughput, and so forth. We will get to it later, but you do have key access here. So if we go into keys, you have the keys set here, and you can actually view the primary connection string in order to connect to this particular account and the details around that. So that is how you would connect to the database once you've got it configured, which we're going to do very shortly. And then you can use these details in order to connect from an external system. So what we're going to do now is we're going to jump into Data Explorer. And this is the main area that we're going to focus on in this session. And it's here where we will look at working with the data, databases, and basically the entities. What we want to do here is we want to create a new container. But in order to create a new container, we need to create a database. So instead of just creating a database using the drop-down and then a container, we're going to do it in one hit. So here we're going to create a database, and this database is going to be for an orders system. So that's what we're going to call it. Then we need to provide a container ID. This is similar to a table. So here we're going to call this orders. We then have to provide a partition key. So this is really around where you want to distribute this data across, let's say, physical partitions on a disk. So what you want to do is you want to choose something that is high in its variance. So what you wouldn't do if you were storing information around a customer, you wouldn't want to necessarily store whether they're male or female, because again, that hasn't got that high cardinality to give us that spread across the data. Now, if we're talking around orders, what would be good for this is, because we're going to be looking around customers, is to basically partition it based on the customer ID. So that's what we're going to do. Then what we're going to do is we're going to set the throughput. So here we're just going to set it up to a standard 400. That is the minimum. So that's what we'll set that up on here. We can, if we want to, set up some additional unique keys. This is tend to be used for validation, etc. But for our purposes, we're just literally going to set it up like that. So let's hit OK. Now this sometimes takes a short while to create, but eventually we'll have a database and a container created where we've got our partition created on the order ID. So it's unique on that side. So if we're pulling back orders for a particular identifier, we've got that there. And it'll also create, obviously, our database containing that particular container. We can just see it's popped up on the left here. So we can expand this out and we can select items in order to view the items that are within our orders container, which there are none at the moment. Now, before we jump in and start creating new items, I just want to cover some of the more advanced topics here with regards to our database and, in this instance, our container. Very similar to relational SQL databases, you've got things like stored procedures and triggers and functions. These can all be set up for containers as well. So again, they'll work in a very similar way. You can have triggers on entry of data, etc. If you're interested in understanding how these work in a SQL relational database perspective, I've linked previously in this video, and I will pull it up above as well, and in the description, a video where I go over some of the advanced topics within SQL. So things like your triggers on updates, your stored procedures, use-defined functions, all of that stuff that's really interesting around SQL. And I use MySQL in order to demonstrate that. Then feel free to check that out. For this particular session, we're really just going to be focusing on the data, how it's stored, and how to query it, just to give you a foundation of understanding around how NoSQL differs to a standard relational SQL database. So let's start creating items within our orders container. So we select new and we get presented with an empty document. And what I'm going to do is I'm going to chuck in here a record for an order here for John Smith, and then I can hit save. Now, when I do that, it creates that. So we've got our ID. It picks the ID up that we set on our partition. So we've got our key here, and then we've got our document on the right-hand side. Now, this document is literally just this. However, within Azure and our Cosmos DB, we get some additional entities or elements put within this data. So again, this is all used by the database system itself. It's all pre-populated in there. We're not necessarily going to dive into what these are, the hashes and bits and pieces and IDs and things here, but it's just so you're aware that this data isn't a mistake. It's there as part of the standard system. So we're going to enter a second item now. So we've got an order here for an Alice Brown. So let's chuck that in here as well. There we go. And then we can hit save on that. And we've now got our 2 records within our document store. So now we've got our records here. Let's look at how we can query and interact with this data. So if we right click on here, we can create a new query. And here it gives you the basic query here to select all records. So we can execute that now, and we can see that we get 2 records back. We get our John Smith order and our order from Alice Brown. So when you're querying, again, very much like standard SQL, you can start using some better syntax here. So we can actually go select all from orders O, and then we can start doing O dot, etc. So if we do that now and execute this, you'll see it gives us the same results. Something to notice as well, very similar to if you're doing any querying in a relational database, you get some query stats coming back. So let's take a look at those. Now, when we look here, we get different metrics. So here we've got the request charge. This is the resource units that were used in order to execute this particular query. Here we can see a select all. In this instance, on a database as small as this, it was a 2.28 resource units in order to pull that back. And it gives us the size of the retrieved documents, etc., and some other details there as well. But really, we're just covering the resource units to understand how queries are made and what the potential efforts are depending on how you query that data. So again, this is a NoSQL database, but we are using the SQL language in order to pull back and query data. So let's do another query. Let's have a look at what would happen if we were to get the record where the ID is 1001. So we're just getting the first record back, which should give us John Smith. So we're going to execute that now. We get 1 record back, and the query stats for that is 2.82. Interestingly, in this particular instance, it's probably down to the container size, that cost more than bringing them both back, because it's had to use the key to do that as opposed to just grabbing everything that's there and just returning it. So again, it works slightly different in the way that the request charge is than what you might expect from something like a relational database. And then we can do another query, again, fairly similar, where we can actually say we want to get an order where the name for the order is John Smith, but actually let's change this and make this Alice Brown, just so that we get a different record back. So let's make this Alice Brown, and we'll execute that. And there we go. Very quickly, we get Alice's order here, and we can see the request charge, the resource units on this is 2.82. Again, quite similar to using the key, but that's likely because we haven't got too much data in here. It just gives you an idea on how we can query this. Now, you can do all sorts here. You can actually do a query where we're actually getting all of the orders where the price is greater than 10. In this case, I'm expecting there to be 2 records. And there we go. So we're not looking at all orders. In this case, we're just taking the SKUs. So give us the SKUs where they have been part of an order that the price is over 10. So we've got 2 of those back, and then we can have a look at here. That's cost us a little bit more. Again, because we're starting to query based on the structure of this particular data here. So something to note that you can do with querying a document store, you can actually query in order to bring back data that looks different than the raw data within a table. A little bit like you can query using SQL on a MySQL database and reorder columns. You can do all sorts of bits here. With a document store, you can actually start creating JSON back and get it to look in a particular way. So here what we want to do is we want to query the data, and we want to bring back the SKU and the sales price of each order. And we want to present that as an object called sales data. So if I execute this, we will now get 2 sales data objects back exactly as we've described in the SQL select here. And if we go to query stats, we can see the effort again to return that. Now we can take this kind of query a step further and actually say, well, we're not really just interested in seeing the product and the sales price. What we want to do is we want to get a product and we want all of the sales, all of the prices, and we want to sum that. So basically what we want is we want to return back the product and the total profit for each product. So we're doing a group by in order to do that. So if I execute this, we'll then get data that represents each product. We've only got 2 here and it's not doing the sum. Well, it will be, but it's only got 1 record in there. So let's go back and actually let's copy our data for this a second. And let's add a new item in here. Oh, that's me not forming it properly. So let's go and put 3 in here. There we go. Let's hit save. We've now got 3 records in there. Now if we go back to our query and execute this, then our product code, which is 20223, if we go back to our ordered items here, 20223 should have a combined cost. We've got 2 different orders now. So we execute this and there we go. We've got some rounding going on there and we can do bits around that. That's not a problem. But there you go. So we've got a group by done on there. But if we then go to query stats, we can now see that's 2.4. And again, what will be interesting, now we've added that in, what happens if we do a select all and we execute that? That's still 2.8, so that's fine on there. Let's do this. Do we get anything more on there? There you go, 2.3. So previously, when we just had 2 records in there, the effort for bringing those back, the resource units, was 2.28, I believe. So again, more data means you've got more resource in order to bring that back because you're pulling back more records, which should actually mean if we go back to doing our ID, so we go .id equals this. Let's see what that executes like. There we go. So that doesn't really change because it's using the partition ID in order to bring that back. The effort for this will always be the same no matter what the number of records are because it's partitioned in that particular way. So we've now gone over how to create a Cosmos database. So we've got a Cosmos DB account, a Cosmos database, and a container. And we've obviously covered the fact that you have keys that you can generate in order to gain access to that particular database. And again, you can recycle and regenerate these when I showed them earlier. So these will now be reset and be different to what they were previously. Again, because I'm creating a demo here, I don't want to obviously expose those particular details. And again, it's so quick to spin these up, which makes Azure really straightforward in order to create databases in this way as part of a test platform or even production, UAT, SIT, etc. Thank you for joining me during this session. If you're interested in anything else database related, check out my introduction to SQL and the advanced session, which covers things like database procedures and triggers. Also, if you're interested in what Azure has to offer with regards to its services and functions, check out my Azure mini-series, which covers things like ETLs, Azure Logic Apps, and many more of Azure's platforms. Thank you.